Good morning, sixth graders. We are starting to wrap up our unit on three-dimensional geometry. Today's assignment is actually going to be a review of three-dimensional geometry concepts, getting us ready for our summative assessment here. So I've actually backed it up to yesterday. This should look familiar. Your only assignment yesterday was to open this three-dimensional geometry notes file that I shared on Google Classroom and just to read through it and make sure we kind of understand here what we've been looking at for the last couple weeks. And our three-dimensional geometry and measurement review actually started with 2D review, right? Because to understand what's going on in the 3D world, we have to have a really good understanding of perimeter and area. And when I think about perimeter, I think about a fence. And remember, when I hear area, then I think about floor tiles. Because the perimeter is referring to, with a 2D shape, any polygon, it's referring to that distance around the outside. That's a linear measurement. But when I hear area, now we're talking about a different type of units entirely. Now we're looking at how many 1 by 1 squares it would take to cover that flat shape, that polygon. So there's still both measurements we talk about with 2D shapes, but one of them is a linear shape. It could be measured with a tape measure or a ruler or a yardstick, where the area cannot now. It needs to be measured in 1 by 1 squares, right? And so we had also on here the formulas for area, finding the area of a parallelogram and the area of a triangle. And then we got into some of the 3D review, naming some of the different three-dimensional solids. Remember, we're talking about things like this, right? It's a rectangular prism, or this triangular prism here, right? Or this rectangular prism. And the idea with these shapes, guys, is they're all made up of polygons. So each one of the bases and the lateral faces are polygons, and once we understand that, then we can start talking about surface area. So when I think perimeter, I think of a fence. When I think area, I think of floor tiles. And when I think surface area, now I think about wrapping paper. And the surface area is basically just finding the area of each of the faces that make up our three-dimensional shape and then adding them together. It would be like if we were trying to wrap this shape, or again one of these, with wrapping paper, but we didn't want any overlaps or any gaps. And so to find that, again, we just are going to find the area of each one of those faces that make up the three-dimensional shape. In this case, it's a rectangular prism, so there are 6 sides. You have the top and bottom, the front and back, and the left and right. And all 6 of those sides are rectangles, so we can just find the area of each one of those by using our formula for the area of a parallelogram. Rectangles are parallelograms, right? And then we add them all together. And then we have the total surface area, or the total area of all 6 faces of this rectangular prism. And when I'm talking about surface area, we're still going to be in square units, because it's really seeing like how many 1 by 1 squares would it take to cover all 6 of those faces. Then we also had a triangular prism on here, which is the same thing, but now we're going to have 2 triangles as 2 of our sides, and then the remaining 3 sides are rectangles. So instead of 6 sides, this only has 5 sides, 5 faces, and 2 of them happen to be triangles. So we just need to make sure we're using the formula for the area of a triangle now, which is 1/2 base times height, or base times height divided by 2. And we use that for our 2 triangle sides, and we still use base times height for the remaining rectangles, right? And then the next concept on here was volume, which is talking about another type of units entirely. Again, it's cubic units. So when I hear volume, I think sugar cubes. Again, going all the way back up here, when I hear perimeter, I think of a fence. When I hear area, I think floor tiles. When I hear surface area, I think wrapping paper. And then when I hear volume, I think sugar cubes. So we're no longer measuring in a linear unit like we were with perimeter. We're no longer measuring in squares like we were in surface area or area. We're now measuring cubes. We're measuring 1 by 1 cubes. How many sugar cubes, for example, would it take to take up the same amount of space as the figure we're measuring here? And in this case, we learned, because we were mainly focused on rectangular prisms here, We learned that the formula for volume is going to be length times width times height. So we have the length of the base times the width of the base times the height of the prism. All right, and then the last thing on here was the net. And so drawing a net of a three-dimensional solid, it's basically if we're going to unfold something, right? So we have this three-dimensional solid, for example, this three-dimensional solid right here, okay? And if it were wrapped up in that wrapping paper, okay, if we were to unwrap it, something like this would give us these different polygons, right? And so understanding what one of these, for example, triangular prisms would look like if we unfolded all the sides, that's what a net is. And so we just really need to look at the three-dimensional shape and count up how many faces it has and understand what those faces look like. And so if you are confused about that on today's assignment at all, this example on the bottom of yesterday's study guide does a really nice job because it kind of labels this, like if with the orientation that this one's sitting on right now, this bottom rectangle is almost a square, it's 12 by 10, but you see it labels that one as the bottom. And here's your 12 by 10. And on the top up here it has 15 by 10, so it calls it the side, but that's kind of like the top face, 15 by 10. And then the one over here on the left is just 9 by 10. So I think this one has a really nice job of kind of spelling those pieces out for you. Okay. And in some of the ones on some of our assignments that we had in this unit, remember they were colored in. Like this one had a blue bottom face and a gray right face. This was on the first surface area sheet that we just done, right? So take that into our assignment real quick. I'm not going to do the assignment with you today. I'm just going to get you started and make sure you understand the different pieces of it. So this assignment will be found in Google Classroom this morning. And it starts out with that rubric of what's going to be on your assessment. And then it starts out, the first page is just draw a net for each figure. So that's what we just saw on the bottom of yesterday's study guide. You're looking at what is a net of a three-dimensional shape. It's the two-dimensional pattern that can be used to create the three-dimensional shape. Again, look back at some of your assignments because it's asking you in today's assignment to draw a net for a rectangular prism, I should say, and a triangular prism. Well, in some of our assignments, that's exactly what we did, right? It had some of them drawn for you, but then there were other ones where you had to draw the net as well. Okay, so look back at those assignments, okay? And actually, if you think about this right now, not only are you looking back for today's assignment, but you're going to be doing this test tomorrow, this assessment tomorrow and Friday, and you still have all these resources available. Yeah, I'm basically telling you it's going to be an open book test or an open note test here. You can use these resources. Here's another one. This is from surface area, I should say, of triangular prisms. Okay, so you guys remember doing this sheet. Well, this was the rectangular prisms one. I'm sorry. Here's triangular prisms, right? And some of these nets are right here for you. And you drew some of them on these as well. Look like this, right? And so number 2 on today's assignment, bringing back today's assignment, the other net was a triangular prism. Right? Then, when you turn the page, or you're going to be scrolling on your iPad probably, the volume of the rectangular prism, which, if you recall, we just had on this note sheet again here, volume is length times width times height. But, again, we'll throw this out here. We had some other worksheets where we explained volume, or we calculated the volume, right, just last week. Some really nice explanations on some of this. So I'm just encouraging you to look back in your notes and at your assignments and past assignments if you're confused at all. But it's length times width times height, so multiplying some numbers here. Oh, bonus! Multiplying with fractions. Length times width times the height. And if you're forgetting how to do those fractions, all right, you can look back in your notes, maybe even have your notebook with you from school. We did some multiplying fractions and multiplying mixed numbers units back in actually September and October. But we can turn these mixed numbers into improper fractions and then multiply them. And I think you'll see some that cross cancel really nice. But you do have a calculator if you need it. And when I'm talking about turning these into improper fractions, remember we take the whole number times the denominator and add the numerator. So 9 times 3 is 27, and 27 plus 2 is 29. So this would be 29 thirds times 6 over 1. And then this is 15 times 2, which is 30, plus 1. So that's 31 halves. So we have 29 thirds times 6 over 1 times 31 halves, which again, you're going to see some really nice cross-canceling out of there if you remember how to do that. But I'm not going to do that for you right now. I want you to give it a try today. And we have a Cheerios box here for our next one, which has a rectangular base of 2.5 inches by 9.25 inches and a height of 12. Well, I just happen to have a Cheerios box right here. Okay, so what they're talking about with that rectangular base is the base that it's sitting on that has a width of 2.5 inches by 9.25 in length, 9.25 inches in length, and then it's saying the height of the rectangular prism, that's what this box is 12 inches, the distance between the two parallel and congruent bases. So now it says find the amount of material necessary to construct the box. That's the surface area. We want the area of the front and the back, and the area of the top and the bottom, and the area of the left and right side. So we're just going to take length times width for each one of those, right? No different than we've been doing all along here. No different than we've been doing all along. We'll do top and bottom, so 2.5 times 9.25, and times 2 because the top and bottom both count, right? Left and right, so 2.5 times 12, and then the front and back, so 9.25 times 12 as well. And remember, you're going to need to remember the same deal with fractions here. So 2 times 2 is 4, plus 1 is 5, so we could treat this as 5 halves. 9 times 4 is 36, plus 1 is 37, so we can treat this as 37 fourths. And when you're doing those multiplications, again, you should see some cross-cancelings in there that'll help a little bit. And then the amount of Cheerios that will fit in the box, now we're talking volume, okay? And so the volume, again, is going to be your length times width times height. So we're just going to multiply those three. Again, use those conversions that we were converting from mixed numbers to improper fractions, and then just multiply those improper fractions. Look for those cross cancelings. And the last problem. Well, it's all number 5. It's a big long A, B, and C here, but it is technically the last problem. ABC Block Company wants to package 16 alphabet blocks in each box. The design company is told that each box must be a rectangular prism designed to hold exactly 16 blocks, no leftover packaging. Each one of those blocks measures 1 by 1 by 1. 1 inch by 1 inch by 1 inch. All right? So this is very similar to when we first started talking volume. Imagine these are your alphabet blocks. Right? And now it wants to put them in a box to ship them. So, like, let's find a box to put them in to ship them. And then how can we design the box so that it holds these things with, like, maximum efficiency, right? And so, like, if we even had, say, 8 of these instead of 16, okay? Well, let's just go with 6. We even had 6 of these. You could design it like this. It'd be a 6 by 2 by 1 high, right? Or, well, I guess we need to do 8 to have a couple different combinations. Hang on a second here. So here, we could do 4 by 2 by 1, right? Or we could do 2 by 2 by 2, right? So you could organize them into different ways to get those boxes. And so that's what it's saying first here is brainstorm all the different possible box designs. All right, I gave you one actually down here. We could have a length of the box, the base of the box of 4, a width of 2, and a height of 2. So you could actually put that one right on here. You could go 4 by 2 by 2. And then there's some others that you could brainstorm. It's actually telling you that there's really only a couple more options that you could have to fill out this part A, different possible box designs. But then for each box design, it says which box will use the least amount of cardboard for packaging. Show your work down here to justify your answer. So it's saying if we were going to wrap up those 16 blocks, which one of those different configurations for the box would be the best, which would use the least amount of cardboard if it was going to be a cardboard box, right? And so to do that, we would have to find the surface area of each of those different box options. Okay, again, you're brainstorming the different shapes that the box could be. Well, they're all going to be rectangular prisms, but the different dimensions of all of those rectangular boxes. And so there's a couple other options on here that you're going to find, thinking about how those blocks could be arranged. And then once you do, you're going to use those numbers that you come up with, and you're going to have to find the surface area of each one of those boxes to see which one would use the least amount of cardboard to make it, because they're not all going to use the same amount. Alright, so that's a little bit of work on that one. It's a little intensive because you're finding surface area a couple of different times, but it's going to be you'll be using a lot of the same math facts, and they're pretty simple math facts, so hopefully you can keep your work organized. That's why I did this example for you here. Like, lay out the different parts of the box that you're talking about, and if you can keep your work organized, you should be able to figure that one out. Another type of block, this is the very last question, has an edge length of 3/5 of an inch instead of 1 inch. What would the volume of this block be? The challenge on this one is, again, just fractions. So don't be thinking too much. Don't be too worried about the shape itself. Just remember here that we're talking volume. So if you need to draw that cube and kind of label the edge lengths as 3/5 for you to see it, to make a little more sense, you can do that. But really, we're just trying to review that multiplying of fractions a little bit on here as well. So we've taken you through today's assignment. Remember, it starts with drawing the net. We're finding volume a little bit on here, surface area of that Cheerios box and volume there. Finding surface area a couple of times with the ABC Block Company. Okay, we got to just figure out the other possible dimensions for the box. And definitely shoot me a message on WebEx Teams if you're having trouble coming up with those. We can work through that a little bit today. And then the different sized edge length of those blocks. So a little work in front of us for today, and tomorrow we'll have a video out here with all the correct answers for this. So give it your best effort today, and we'll see you again tomorrow.